Hey guys, welcome to today's stunt rigging toolbox talk. Today we're going to talk about gold tails. Here's an old one from SRT in Australia, and here's one of the new ones that I make, which is basically a copy with some changed radiuses, which is important, and I'll explain why. I have to say I love and hate this device. It is basically caveman technique. It is kindergarten, but the thing is that it's very effective. It can be used with high speed, low speed. It is a friction brake, period, simple thing. It is taking a piece of rope and breaking it over an edge and causing it to also change direction in multiple direction changes to create friction and thereby slow the speed of the rope going through it. It's pretty simple. It's exactly the same technique if you take a bite around a piece of pipe when you're lowering something with one wrap so that you can control it while you lower it. It's the same device as the arborists use all the time, is a bollard. It's a large round cylinder of metal that normally has, you wrap the rope around it 1 or 2 times, depending on how the weight is, and then you can lower things, or they use them autonomously with a minder on the tail so it doesn't whip, to just drop limbs when they top trees. It works quite effectively. It just is a friction, a progressive, and well, it's not real progressive. It can be progressive, but a friction device where it's a known variable of friction, so you know what you're getting every time. So with so many wraps, you learn what it takes to slow the object and how fast. And most of them you can automate by putting weight on the end or putting a bungee on the end of the free tail of the rope, and thereby give it the same amount of friction, the same amount of resistance every time. Typically it's used in hand. You let it work its magic and then you friction it and bring it right up to a stopping point. We use this for superhero jumps, drops from relatively low, 10-meter or less distances. I use it when people get ratcheted towards a wall. I put an X line on them so that when they get to that point, I can stop them there without slamming into the wall. And because of the sudden stop, it looks like they're hitting the wall, but it actually has a little bit of decel, so it's not just a dead man. So there's a million things you can do with them. I am redoing this video and I'm gonna break it into parts today because I went down the rabbit hole. I started this video and I was gonna post it a couple weeks ago, and I realized it was 37 minutes and I had only scratched the surface because there are so many variables. So first I'll show you what one looks like, then we'll talk about what it does and how you put rope in it, and that'll be it for today, okay? So we'll just keep it easy. Here's a gold tail, one of the original SRTs from Australia, single rope technique. These go back, a similar device, these go back and kind of took the place of a Petzl rack, which was a wire loop that had various round steel and/or aluminum bars that you could slide up and use 1, 2, 3. You could put them closer or farther, and it's used for descent, for heavy weights. Okay, so it has the potential to be able to decel quite a bit of weight and to lower. I mean, you can run this with 5 holes and put someone on it, and you never have to touch it. They just progress down the rope because of the amount of friction is almost equaling the load. So that's what it is. It's usually now made out of aluminum. This old one has a sort of powder coating on it, which you can see is wearing off in various places from the rope friction. It has a radius on each of these holes. It has an openable, closable gate so that you can load the rope in it. You open the gates, you put a rope through it, you slide the gate so you can bring the rope up through it, pretty much like this picture here. I would use this eye to go to my tech, or quote unquote to my performer, and this part would be the part I would monitor or hold. Now when you use this device, you always want to be pulling back against the spine. Notice there's a spine and there's an open side. These gates move. You don't want the rope running there. So whatever you do, you need to be monitoring it so that it comes and rubs on this inside spine, not on the gate side. That's the first thing when you set these up. The second thing is, a lot of people, and I disagree and don't like it, so I do something a little different, like to run them vertically. So you'll see a piece of truss with a goalpost at the end. They'll put tube up with cheeseburgers on both sides with scaffold clamps, with aluminum scaffold clamps, whatever you want to call them, whatever country you're in. And then bring a cross beam across. This will rest, this will be clipped to the truss, and this will have rope or tack or gash or something, bungee, up to this goalpost. So it's standing in a vertical orientation. Rope comes down from the reds, the crane, whatever rigging is above it, and feeds in to this device. Okay? I don't like that because it means you have to build something, you have to hold something up. I prefer to run this device locked flat on the truss. So you have a truss pinned to the floor, standard operating station. And our trusses all have turnaround shivs on the end of the truss. So they're fixed pulleys that take any up line and redirect it parallel to the truss at a specific center line that everything is designed for. A lot of guys are using sailing pulleys at the end. A lot of guys just put a span set and a pulley at the end and come down, but they flop around. Ours don't flop around. Needless to say, what you do then is you anchor this at the midline with a span set ratchet strap on the front to hold it down and tight. Sometimes you can put a bar across the front, but you mount it physically fixed. Okay, so that this line runs where you need it to run, and you have control of your friction line where you can always break it back over the spine. Okay? And that's how you run them. Now, when we're dropping people, we typically have enough slack to allow it to run fairly fast so it looks like they're falling, and then you would apply friction with your hand. Another technique is to set it up with a weight bag, do it a few times, and come up with a way to attach to this line that's in your hand, attach a bungee to it so that as it progressively pulls on the bungee, it gets to a point where it's adding more and more resistance till it comes to a stop at the mark you like. Which is nice because then there's no incidences with operator error. It's always the same. It takes a little longer to set up because you have to do enough drops to know what you're doing, but it also is very smooth. Another way to do that on an easy descent is to put a weight bag on the end of this. 10 kilo, 5 kilo, whatever it takes, especially with various fight sequences where people are jumping and kicking. Sometimes they put a back line on them so that they don't kick through the person. They kick the person, but they've lost their forward momentum. And thereby it looks good, but it drag breaks them. It slows them down through this device by pulling just enough rope. And as I mentioned before, it's the same scenario. When I ratchet someone to a fixed point in space, what we'll do is we'll put enough decel in it to where it's not a sudden dead man, and then we'll probably put a knot behind that, which is a butterfly usually, so that it comes to a dead stop at a specific point every time. And there we can drag, slow down the movement, and then stop them specifically at a point so there's no more forward momentum. This is how we use this device. It's super simple, but all of these nuances make a huge difference. First nuance, these are the ones we make. They run hand in hand. The rope, most people run through these because we're in stunts and because we want a very specific, accurate stopping point each time. We tend to use what you can call it zero stretch rope. It's a 1% stretch rope. One of the ropes of that is Samson puts out a T100. It's a polyester jacketed Dyneema 12-strand core rope, which was a standard for a long time in a lot of countries. The UK uses it a lot. They love it. I particularly hate it. It's a polyester jacket. This is a friction device. So what happens is, if it's fast, if it's long, what happens is you glaze the polyester jacket, because what's a byproduct of friction? Heat. This is a big heat sink. As this rope goes through generating heat, it glazes the jacket. So you end up with a crunchy jacket on T100. So what I started using was this rope, which is designed for grinder winches and clutches on big sailboats. And this rope is super beautiful, super flexy. That end's a little stiff because it has a big long splice in it, as you'll notice, because I splice eyes in these. This is where I would connect to the tech line we use to go to the performer. I'd only use a tail to run through this device of this rope. So this is the tail of this splice. So it's a little stiff. But the rope itself is extremely flexible. This rope also has a Dyneema 12-strand core. And this rope has a Technora jacket. Now, It's designed for winches and clutches, which are high abrasion applications on very large mega boats, mega race boats. So this is an ideal rope to use. It has a good hand. It handles the heat and the abrasion without glazing, without causing any problems. And when you pull on it, it will get tight and then it flexes right back up. Okay, so it has an extremely good hand. Now, in saying that, using this rope, because of its high friction coefficient on its jacket, it's a 32 strand jacket with Technora. It's very abrasive, so it generates a lot of friction. So what I did was, when we built these new ones, we changed the radius, the entry and exit radius on the small slots that the rope is fed through. Otherwise, it's pretty much the same device as the original, but this allows the rope to flow a lot nicer. It's not so grabby, and it works better with this rope application. So that's what we did, because the new ropes, a lot of people hated it when I started using it, and now they use it a lot. Various people are using it because it is such a beautiful rope. You don't wear it out, it doesn't glaze, doesn't get crunchy. So in order to accommodate that and not have things run more friction than you want, we've changed the radiuses, and we hard coat anodized, because the powder and or normal anodizing that goes on a lot of these products goes away. This is mil-spec hard coat anodizing. You can't scratch it. You can take a knife to it. And it holds up a lot longer under the abuse. So that's what we do with these. Otherwise, it's pretty much the same as the original. Now, rope selection becomes to be a real big point on these, because it's friction based. So anything that adds or subtracts friction will make it either run faster or slower. If you've got a 12 mil rope that's super high friction, like this jacketed rope, then you're going to have a lot of friction, which is great if you've got 80 kilo guys. You can go several holes, 2 hole, 3 hole, and still control them. If you have someone light, it gets to be an issue, because anything you do is a bit too much. So then you can run a 10 mil strand of rope of the same rope, or if that's too much for the activity, you can switch to a smoother jacketed rope. Like I have some Vectran I use that's 10 mil and 12 mil, and it has a 24 jacket, much softer, but it's a much shinier, smoother jacket. And it flows through this even way faster. So if you have a 50 kilo or 40 kilo person, you go to a 10 mil with a jacket like that, now you have maybe need to even grab another hole, but you have a 5-hole gold tail to work with, so you can set the friction and it's easier in the parameters you're working. So that's why I always use 5-hole gold tails, because I don't have to use them all. And you can adjust the friction in these. You can go 2 holes back to back. You can skip holes. You can take it out, and if you want, skip the entire, which will now, with the less change of direction that you have, and only the friction on this main bar as it pulls through, you will have less friction. So you can play games like this. You can go bar to bar to bar, which the constant in and out adds a lot of friction, one right after the other. Like this, on a 5-hole gold tail, you'll have maximum friction. I can close the gates up so you really see what it looks like. Okay? You will have your maximum, because notice the direction change and the friction over each bar. That's maximum. You'd be hard pressed for a 200 pound or 190 kilo person. You could put this and just let them just drop, and they will just barely slide down the rope from a high altitude. This would be like walking down a wall, no big deal. In fact, it'd probably be too slow for even that, unless you got some kind of jump into it to get the speed moving to start with. Which brings us to a point, when you use this, a lot of times it's not a static maneuver. It can be a dynamic jump off of something into slack, and then into the gold tail to slow them down to land. Which then means the rope will need to pull through, and then you will need to add friction on the back end to slow them down. Which usually comes from monitoring, which usually comes from breaking this over the spine, so you're running in these corners here. So the rope comes here, and it's, as you monitor it with friction in your gloved hand, you can slow it down. And the more friction or more change of direction you put on it, if it's running horizontally in this direction to your performer, and you pull this way, you're putting more against the spine until you can actually pull back. You have this whole wrap range plus the grip in your hand. So again, like I said, it's a simple device, but it requires quite a bit of style and form to be able to use correctly. The thing to remember is we use it for braking, we use it for decels. Its main advantage is it is much more predictable. It has much more regular friction content to each hole. You know how much more it's going to bring. It helps pull heat out of the stop because it's a big heat sink, so this will get warm. I've had some instances where it's gotten red hot, and I immediately have to get the rope out of it so I don't start hurting the rope. But the fact is, you can use it in a range of ways, and you can run it vertically if you like. I don't like it, so I run it horizontally and lock it in. The main thing is to always do a few tests. And a quick side note on that is I was pressured in to hurry, and we had a very lightweight person jumping onto one of these. It was a 10 meter, 12 meter drop. Jump into it, look like they're falling, decel them, land on the floor. Didn't do a bag test, and I had this rope, 12 mil, and a couple of holes, and it was too much for the person that was only 50 kilo. And so they were very slow, and the first hit into the rope was quite a significant braking as opposed to pulling rope through, even with no friction from my hand. So what I've learned is you always need to first always lower someone on this to see how controllable their weight is on how many holes I've chosen, how many bars. And then I will have them jumping into it. I will have them going into slack to see how far I can get them accelerating and still slow them down. It's a step-by-step process, and writing each one of these down as you go. And that way you can achieve a really good look, the classic superhero three-point landing, Thor, etc. This is the object used. The one thing about these you have to always be aware of is the rope management is the biggest issue with these. Rope management is something you really need to pay attention to, because with this much rope pulling through and that much tail sitting on the floor. So as you pull this, now if I was to run this all the way up, I mean, I don't have to, but yeah, just so you can see it. Let me set it up here. So once I have all the holes here set, it's locked, the performer is on the end of this line. Now I can see how many changes of direction and how much friction's on this. We want to make sure it's running against the spine, and then I will know if I need to break it more against the spine or let it run. And you have to be just very aware of little changes. It's a finesse device, folks. And it really depends on the rope you use, the way you orient the device, besides the number of holes and the friction from your hand. All these play into this. one thing I do have to say is this is rope management from this, because the tail twists. As you pull it through, this rope will twist. So you end up with a tail that is twisted. And a lot of times if it's a long amount of rope at the back, so you have a pile on the floor and just an open length you're using, the twist will build up in that. You have to constantly get that out for the next pass, or else you'll end up trying to run something like this through the gold tail and it will bind up. You'll get either a judder as it unwinds in that, or it will just suck itself in and lock and stop the performer, which can be not so advantageous if it's in the middle of a pretty good run. So you have to be aware of your rope management. A way to prove that would be clip this on your harness, go up in the air 10 meters, load the gold tail, and then just slide down it and watch with the tail. Make sure the tail of the rope is at floor height. If you want to be safe, always put a barrel knot in the end. But just let yourself slide down and watch what the tail does. The tail's going in circles. Okay, it's wrapping around. This device is stationary, the tail is moving. And that is just the nature of the friction and how it rotates in the grooves. And it doesn't even have to be full rotations, but it will whip and it'll create assholes in the rope at the end. So if that's laying on the floor, there's no way to get those out in the middle of a run. So you have to make sure you pay attention to that each time, just as a side note. So that's it for today. We're going to keep it short. And we'll come back. Next time we'll be showing how we test gold tails for strength. This one's marked 600 kilo working load limit. And we'll also show how they rig up. I'll get my lazy ass out in the trailer and pull down some truss and a turnaround plate and a few other things so I can just set it up in here and do a quick approximation of how they're set up. Okay? A really good device. Like I said, a love-hate relationship with it. But enjoy them. It's a great way to slow things down, break things. As a friction brake, it's pretty indestructible once you learn how to use them. And the only good way is to practice, practice, practice. On shows, we have contests and play games. I'll see if I can come up with some videos to post of trying to stop a bag just above an egg. Things like that entertain the boys when we're not on set. Okay? Well, have a good day. Thanks a lot.